When astronomers first detected 3I Atlas, the signal looked ordinary. Just another faint dot moving through the sky, but something about its trajectory caught attention almost immediately. It wasn't following the curve of any known orbit. Its path sliced through the solar system like a line drawn by another hand, a straight hyperbolic arc that could only mean one thing: this object didn't belong here. At the University of Hawaii's Atlas Observatory, Dr. John Tonry, one of the system's lead scientists, was among the first to confirm it. In his report, he noted, its incoming velocity is too high for gravitational capture. It's interstellar. That word interstellar has a way of changing the tone in every room it's spoken, because it means this rock, this small traveler, has come from somewhere beyond the reach of our sun's light, a messenger from another star. To put that in perspective, only 2 other interstellar objects have ever been confirmed in human history: Oumuamua, discovered in 2017, and Borisov in 2019. Both rewrote textbooks, and now 3I Atlas III was about to give us a chance to study such a visitor not from afar but as it passed near Mars. Here, NASA's Jet Propulsion Laboratory quickly assembled a review team to assess whether any existing spacecraft could be repurposed for observation. It was decided within 48 hours the Mars Reconnaissance Orbiter, MRO, and ExoMars Trace Gas Orbiter would serve as humanity's eyes for this event. They already had high-resolution cameras, spectrometers, and enough fuel to adjust their orbital timing for a brief window of opportunity. That window would last less than 2 Earth days. The team called it Operation Atlas Flyby, and for good reason. The geometry was almost impossible. 3I Atlas would cross the Martian orbital plane at a distance of roughly 0.015 astronomical units, about 2.2 million kilometers, an interplanetary blink. If the timing failed by even a few minutes, Mars would turn away, and we'd miss the only chance in centuries to study a body from beyond our star. As the countdown began, the world barely noticed. The event wasn't as glamorous as a Mars landing or a new rover, but to scientists, this was bigger because if 3I Atlas carried materials untouched since another sun was born, it could hold the oldest sample of alien chemistry ever recorded. Imagine a fragment that formed before the Earth itself. Now picture the scene at NASA's Mission Control that morning. Monitors glowing in the dark, data streaming line by line, numbers, frequencies, timestamps. No fanfare, just quiet focus. The first light from 3I Atlas reached the high-rise camera on board the Mars Reconnaissance Orbiter around 03:26 UTC, March 17, 2025. A faint streak appeared across the Martian sky. At first it looked like nothing, just reflected sunlight on a distant ice body, but the spectral data told a different story. Infrared readings showed strong absorption around 3.3 micrometers, indicating polycyclic aromatic hydrocarbons, complex organic molecules often found in interstellar dust clouds and, interestingly, in prebiotic chemistry on comets. These are the same compounds that NASA's Stardust mission found in particles from Comet Wild 2 back in 2006. They're building blocks not of life itself, but of the chemistry that makes life possible. That finding alone would have made headlines, but something else caught their attention. 3I Atlas wasn't just reflecting light, it was emitting it in a narrow repeating pattern. Microwave data from the ESA's Mars Express probe revealed a rhythmic signal every 11 minutes, consistent but unexplained. The team initially suspected a rotational pulse like a natural lighthouse effect. Yet the frequency remained constant, unaffected by distance or angle. That's rare, extremely rare, for an object of natural origin. To confirm, the team cross-referenced data from the ALMA Observatory in Chile and the Deep Space Network in Canberra. Same interval, same signal, a periodic microwave emission coming from an interstellar comet. Now, before jumping to conclusions, scientists are careful, and rightly so. Many natural phenomena can mimic structure crystallized metals, magnetic realignment, even layered ices. Still, as one NASA engineer put it during the press debrief, we don't have a template for this. You might be wondering why Mars. Why does it matter that this object passed near the red planet? Because Mars gives us a kind of cosmic contrast background, a stable vantage point with thin atmosphere and known radiation levels. If 3I Atlas interacted with that environment in any measurable way, we could detect trace gases, dust, or chemical residues that reveal its makeup. In other words, Mars acts like a natural detector, a giant laboratory waiting for something to drift by. And drift by it did. When 3I Atlas's faint tail brushed the outer atmosphere sensors on the ExoMars Trace Gas Orbiter, recorded a sudden rise in methane levels, fleeting, but undeniable. It lasted for about 5 hours, then faded. Now methane on Mars is a mystery all by itself. We've seen it appear and disappear since 2003. But the timing right as 3I Atlas passed reignited an old question. Could something in the dust of interstellar objects carry the chemistry of life across worlds? At this point, the data wasn't enough for answers-only questions. And that's what makes moments like this so powerful in science. The excitement isn't in what we know. It's in realizing how much we don't. Have you ever looked up at Mars, that small orange dot in the night sky, and thought about how fragile our knowledge still is? Every new discovery reminds us that the solar system isn't a closed story. It's still being written by forces far older and far stranger than we can yet imagine. And as the observation window closed, the team prepared for the next phase, decoding the chemical fingerprint of this traveler to find out where it came from and maybe what it has brought with it. Next, we'll look closer at what those first spectra revealed and why one detail in the data sent shockwaves through every major observatory on Earth. Right now, somewhere beyond the orbit of Mars, a silent object is crossing our solar system, an object not born under our sun. It's not the first time this has happened. Each time a traveler from beyond appears, our instruments strain to capture it, and our understanding of the universe shifts just a little bit further into the unknown. In 2017, astronomers in Hawaii detected the first of these visitors. The Pan-STARRS telescope caught a faint, fast-moving object slicing through space at an impossible trajectory. They called it Oumuamua, a Hawaiian word meaning a messenger from afar. It wasn't shaped like a comet. It was long, thin, metallic, almost like a shard of something greater. And as it spun and accelerated slightly, scientists realized it wasn't being pushed by jets of gas or dust. It was simply moving on its own. No one could explain how. 2 years later, in 2019, another appeared, 2I Borisov, discovered not by a space agency, but by an amateur astronomer with a homemade telescope. This one looked familiar, icy, with a glowing head and long tail, but its chemistry was alien. Spectral readings revealed cyanide-rich ices, far more concentrated than any comet native to our system. 2I Borisov proved that interstellar objects weren't one-off miracles. They were real, measurable, and perhaps common. It also hinted that the galaxy is full of wandering messengers, each carrying the story of its home star. And now there's 3I Atlas, the third interstellar object ever found. At first it seemed ordinary, a faint speck discovered by the Asteroid Terrestrial Impact Last Alert System in Hawaii. But when telescopes tracked its movement, something didn't make sense. Its trajectory was too perfect, governed entirely by gravity. No jets, no drag, no acceleration. Yet, when the Hubble Space Telescope captured images in July 2025, it revealed a jet of gas escaping straight toward the sun as if ice were sublimating from its surface. That should have altered its path. It didn't. To the naked eye, it was a contradiction, losing mass, yet moving flawlessly unaffected. Harvard astrophysicist Dr. Avi Loeb and his colleagues compiled over 4,000 data points from 227 observatories across the world. Every calculation confirmed the same thing. The object's motion was 100% gravitational, even while it shed 150 kilograms of material every second. Loeb later wrote, "We're witnessing a phenomenon that fits all equations and yet feels wrong. That's when discovery begins at the edge of our understanding. So what could it be? Some suggested exotic materials, solid hydrogen, superconducting dust, or metallic ice that evaporates invisibly. Others whispered bolder theories that 3I Atlas might be a fragment of an artificial structure, perhaps debris from another civilization's technology, drifting through the void. It's a wild idea, but then again, so was the notion of interstellar comets until 2017. History reminds us how often the universe humbles us. In 1977, a radio telescope in Ohio captured a 72-second transmission unlike any natural signal, the WOW signal. It never repeated, and no one could explain it. Now, nearly half a century later, 3I Atlas stirs the same emotion, the sense that something out there is trying to tell us a story we don't yet understand. Imagine standing on Mars tonight. The thin red sky above and a silver streak gliding silently overhead, a wanderer from another sun carrying the frozen chemistry of a world you'll never see. Not alien life, but alien memory. Every interstellar object we found is like a cosmic letter drifting through time and space, waiting for someone to read it. And this, our third letter, feels strangely personal. Perhaps the universe isn't silent at all. Perhaps it's been speaking all along in the language of light, gravity, and dust. We just needed the right instruments and the right kind of patience to hear it. Because when we study 3I Atlas, we're not just looking at a rock. We're looking at a messenger from another system, a piece of matter that has traveled billions of years to pass briefly through our sky, carrying clues about where life itself may have begun. If stories like this spark your curiosity, stay close, because what scientists discovered next when they raced to capture its image from Mars would challenge everything we thought we knew about the space between stars. Right now, deep beneath the California desert, in a windowless control room at NASA's Jet Propulsion Laboratory, a small team of engineers stares at a countdown clock glowing red. They have 48 hours to capture the first close-up image of something born beyond our sun before it disappears forever into the dark. Because 3I Atlas isn't just passing through the solar system. It's heading toward Mars, and for a brief, impossible moment, the red planet is in the perfect position to see it. If the alignment holds two orbiters, NASA's Mars Reconnaissance Orbiter and the European Space Agency's Trace Gas Orbiter could turn their cameras away from Mars itself and point into the void. For the first time in history, humanity could watch an interstellar object up close from another planet. But there's a problem. Neither spacecraft was built for this. Their instruments are calibrated for Martian dust, not deep space. Their cameras can't even lock onto a target moving at 36 kilometers per second. Every calculation has to be redone manually, line by line. Each line of code uploaded across hundreds of millions of kilometers must be perfect. There is no second attempt. At 03:26 UTC, the first data stream begins. A grainy signal, static, and then through the noise, a faint streak of light moving across the blackness, a line so subtle that half the room misses it at first. But when the filters clear and the color correction sharpens, the line becomes a shape, a solid object, irregular, glowing faintly along one edge as sunlight grazes its surface. It's not smooth. It's fractured, layered, as if made of plates of crystal fused together by unimaginable pressure, and it's spinning, not randomly but rhythmically, a full rotation every 11 minutes. That's the same period reported earlier in the strange microwave signal detected by ESA's orbiter. Coincidence maybe, but coincidences are rare at interstellar scale. Spectral data starts coming in. The first surprise: no water, no carbon dioxide, not even silicate dust, the basic ingredient of every asteroid we've ever studied. Instead, there's a narrow spike in the infrared spectrum around 3.3 micrometers, the unmistakable fingerprint of polycyclic aromatic hydrocarbons, or pHs. These are complex organic molecules, the chemical scaffolding of life. They've been found before inside meteorites that crashed on Earth and in the tails of ancient comets. But never this pure, this dense, this organized. NASA's Dr. Michelle Thaler looks up from her monitor and whispers, "It's almost like someone baked these molecules together and then froze them in time." Over the next few hours, more readings pour in. The object's surface temperature fluctuates by only 2 degrees even as sunlight hits it. That's impossible for any ordinary rock. It suggests that beneath its crust lies a material capable of redistributing heat like a thermal conductor, or a design meant to keep it stable. At ESA's Operations Center in Darmstadt, Germany, a scientist laughs nervously. If this is natural, nature is better at engineering than we are. The atmosphere in both control rooms changes. No one's talking about comets anymore. The data doesn't fit any known model of natural formation. It's as if 3I Atlas is made of the same stuff as the dust between galaxies' primordial material from before the sun was born, bound together into something that moves with purpose. Then a small anomaly appears in the data log, a pulse of reflected light repeating exactly every 11 minutes and 4 seconds, synchronized with the object's rotation. It's not strong enough to be a transmission, but too regular to be noise. Imagine a lighthouse beam sweeping across the dark, not to signal, but simply because it turns. Still in the silence of space, it feels deliberate. Around the world, observatories point toward Mars. In Hawaii, the Subaru telescope captures the faintest glimmer of the same rhythmic reflection. In Chile, ALMA confirms it. 3 independent observations, 1 pattern. By every scientific definition, 3I Atlas is now the most mysterious object ever studied. For a brief few hours, humanity is looking through the eyes of another world, and the view isn't comforting, it's humbling. Because the more we learn about 3I Atlas, the less it resembles anything we've known, and the more it feels like a messenger from a civilization written in physics rather than language. But soon, the signal fades. The orbiters turn back toward Mars. Data stops streaming in. 3I Atlas drifts onward, past the red planet's orbit, heading toward the outer reaches of the solar system. Its light weakens, swallowed again by the black. In the quiet that follows, a single line of code flashes on the NASA console, a checksum verification of the final frame. When they decode it, there's nothing but random pixels. Except for one peculiar detail, a cluster of points forming a pattern eerily similar to a double helix, the same geometry found in DNA. Is it coincidence artifact or something else entirely? No one can say, but in a universe built on math, patterns rarely appear by chance. Back in Pasadena, Dr. Thaler turns off her monitor and says softly, "Maybe this is how the universe speaks, not in words, but in structure." Outside, the California night is quiet. Above the city, Mars glows faintly, and somewhere beyond it, 3I Atlas keeps moving, carrying its secret with it. If this story leaves you wondering what else might be drifting out there, stay with us. Because in the next part, scientists will decode what those final chemical fingerprints mean, and how they may rewrite everything we thought we knew about the origins of life itself. Somewhere in a quiet data lab at NASA's Goddard Space Flight Center, the lights are dimmed. Rows of monitors glow with one question: what is 3I Atlas made of? The last signals from Mars have arrived, and what they reveal will divide the scientific world in half. At first glance, the data looks ordinary, just wavelength peaks and chemical lines. But as scientists begin plotting the spectrum, they realize something extraordinary. 3I Atlas carries the signature of heavy hydrogen deuterium at levels 3 times higher than any comet in our solar system. That single isotope tells a story. It means this object was born in a region of space colder than the sun's cradle, perhaps in the outer shell of another galaxy's protoplanetary disk. In other words, it's older than our solar system itself. Next, there's the organic chemistry. The spectral analysis lights up around 3.3 micrometers, the mark of hydrogen cyanide and polycyclic aromatic hydrocarbons, PAHs. These are the same complex molecules that when bathed in ultraviolet radiation can transform into amino acids, the building blocks of life. We've seen them before inside comets and meteorites, even floating in the gas clouds of Orion, but never this pure, never this structured. In one of the labs, an astrobiologist leans forward and whispers, "It's like this thing is carrying the recipe, not the meal." Across the Atlantic at the European Southern Observatory in Chile, scientists run comparison models. When they overlay the Mars data onto previous comet spectra, the difference is staggering. 3I Atlas doesn't behave like dust or ice. It behaves like something engineered by natural chemistry, layered, self-stabilizing, capable of withstanding radiation without decay. It's as if it evolved to survive interstellar travel. Dr. Avi Loeb at Harvard writes in his notes, "If an object can endure 1 billion years of cosmic radiation and still hold its molecular integrity, perhaps we should redefine what we mean by life." But that statement sparks outrage. Forums explode. Is it life or just chemistry behaving beautifully? Skeptics argue the readings could be distorted, that what looks like order might just be the chaos of space pretending to make sense. And yet, the data refuses to fit that narrative. Inside the final high-resolution frame from Mars, the infrared sensors detect something no one expected: patterned temperature fluctuations, not random, but cyclical, forming hexagonal arrays across the object's surface. Nature does this only in extreme systems, Saturn's poles, crystal lattices, molecular membranes, but never on a moving interstellar rock. When the visualization is enhanced, the result takes everyone's breath away. The surface of 3I Atlas looks like a frozen coral reef of carbon, tiny ridges repeating in mathematical harmony. If nature carved this, it's the most precise chaos we've ever seen. Dr. Michelle Thaler, watching from her office at NASA HQ, murmurs, "This isn't randomness. This is symmetry, trying to remember something." For a moment, everyone in the room is silent. The data on screen isn't just science anymore. It feels like language, a story told in molecules, a whisper from a place that existed before time had a name. Somewhere in that pattern may lie the oldest message ever written, not in sound, but in structure. Maybe the universe doesn't communicate with words or radio waves or symbols. Maybe it speaks through chemistry, through the way atoms choose to hold hands across eons. That's when one of the younger researchers asks, "If this thing carried life's ingredients here billions of years ago, would that mean we're descendants of the same dust?" No one answers. But the question lingers in the room like gravity, invisible but undeniable. Outside, the night sky over Chile is clear. Mars burns faintly red above the horizon. Somewhere far beyond it, 3I Atlas is already gone, slipping back into interstellar darkness. Its light fades, but its fingerprint remains stored in petabytes of data in the minds of every scientist who saw it. Maybe one day we'll find another. And when we do, we'll know what to look for, not just the glow or the orbit or the chemistry, but the pattern, the pulse, the symmetry that connects everything alive to everything that's ever drifted between the stars. So tonight as you listen, imagine it, a fragment older than Earth, carrying the memory of creation itself, whispering softly through the void. We were never alone. We were always part of this. Right now, in a dim lecture hall at Harvard, the lights have just gone out. A single projection glows on the screen, the chemical fingerprint of 3I Atlas. Dr. Avi Loeb steps forward, folds his hands behind his back, and says softly, "This might be the oldest story ever told, written not in words, but in molecules." Around the world, the data has ignited a new debate, one that reaches far beyond astronomy. Because if 3I Atlas carries organized organic chemistry older than our sun, then it may not simply be a visitor. It might be a messenger of life's origin itself. The hypothesis isn't new. More than 2,000 years ago, a Greek philosopher named Anaxagoras suggested that life's seeds drift through the cosmos, landing wherever conditions allow. He called it panspermia. In the 20th century, Fred Hoyle and Chandra Wickramasinghe revived the idea, arguing that comets could carry microorganisms between stars, but for decades, no one had proof, only speculation. Then came the data from 3I Atlas: hydrogen cyanide, aromatic hydrocarbons, stable carbon lattices, and most shocking of all, a pattern of temperature oscillations matching the natural rhythm of protein folding. It doesn't mean the object is alive, but it suggests it could have preserved the chemistry of life long enough to spread it. Inside NASA's Astrobiology Division, simulations begin. Supercomputers model what would happen if fragments like 3I Atlas struck a young Earth. Under ultraviolet radiation, the molecules reorganize spontaneously, forming amino acids and sugars within hours. Its chemistry behaving like intention, like memory encoded in matter. Dr. Michelle Thaler leans over a monitor and says quietly, "Maybe evolution didn't start on Earth. Maybe it arrived already halfway written." Outside, the lab's controversy erupts. Some call it romantic nonsense. Others see it as the missing piece in the story of creation. But every telescope that turns toward the sky finds more debris, more icy wanderers carrying the same spectral fingerprint. The galaxy, it seems, is full of couriers. Meanwhile, deep in Chile's Atacama Desert, the ALMA Observatory detects another faint signal, an object smaller than 3I Atlas, following a similar interstellar path. Astronomers nickname it the Echo. It's still billions of kilometers away, but its light curve shows the same 11-minute rotation period. If confirmed, it means 3I Atlas was never alone. Perhaps there's a whole family of travelers, a migration of molecular archives drifting between star systems, rewriting the universe one planet at a time. For a moment, the implications overwhelm even the most skeptical scientists. If these objects carried the ingredients of life across time and space, then every living being on Earth or anywhere shares a common ancestor, not of flesh, but of dust. We are children of interstellar chemistry. Dr. Loeb looks out the window at the cold autumn night and murmurs, "We spend centuries searching for aliens, but maybe the aliens are already in us, written in the atoms that remember where they came from." The thought lingers. Because if true, it changes everything. Religion, philosophy, the meaning of isolation itself. The universe wouldn't just contain life. It would be life, vast, ancient, and endlessly recursive, breathing through the chemistry of its stars. Imagine that for a second. Every breath you take carries atoms once part of a comet older than Earth. Every heartbeat echoes a rhythm first pulsing inside a molecular chain drifting between suns. And somewhere far beyond Mars, another traveler is on its way, silent, patient, carrying another chapter of the same eternal story. So tonight, as you look up at the sky, remember, we are not just observers of the cosmos. We are its continuation. The same patterns that glow inside 3I Atlas glow inside us. And maybe that's all the proof we'll ever need that the universe was alive long before we learned how to name it. It started with a sound that no one was supposed to hear, not a voice, not a message, just a rhythm. At 02:47 a.m. on December 12, 2025, the ALMA Observatory in Chile picked up an anomaly, a faint pulsing signal repeating every 11 minutes and 4 seconds, the same interval as 3I Atlas's rotation. At first, they thought it was equipment noise, radio interference, satellite echo, solar wind reflection. But when they cross-checked with telescopes in Hawaii, Australia, and Greenland, the same pattern appeared, each one exactly in sync, each one coming from a region of space now empty, the path 3I Atlas had left behind. The data didn't look like a transmission. There were no encoded frequencies, no modulation, no artificial tone. It was something else, a standing wave, a repeating electromagnetic resonance, as if the fabric of space itself were humming. When converted into audio, it sounded like a soft heartbeat wrapped in static, slow, deliberate, hauntingly steady. Dr. Rosa Dufresne, a radio astronomer from France, was the first to say it aloud. It's not coming from the object, it's coming through it. Across NASA and ESA servers lit up as physicists began modeling the signal. The rhythm matched a mathematical constant buried deep in quantum field equations, a repeating pulse tied to the oscillation of hydrogen atoms. In other words, it wasn't random, it was universal. For the first time, scientists wondered if 3I Atlas had done something impossible, triggered a resonance in the vacuum of space, a kind of quantum echo that kept vibrating even after the object was gone. Dr. Avi Loeb called it the universe remembering an encounter. Others called it nonsense, but no one could deny what happened next. Over the next 48 hours, radio telescopes across Earth detected subtle phase shifts, as if the signal wasn't a single pulse, but a pattern moving across the planet. From Chile to New Mexico, from Sweden to South Africa, the same pulse swept across the globe, every 11 minutes, every time perfectly synchronized. Then came the strangest discovery of all. The waveform's harmonics, when plotted, visually resembled the same hexagonal symmetry pattern detected on the surface of 3I Atlas weeks earlier. 6 repeating lobes interlocked like honeycomb geometry, or perhaps more precisely, like the cross-section of a carbon nanotube. Mathematically flawless, too precise for noise. For a few nights, the scientific community stayed awake, watching the skies and the data screens in awe and disbelief. No one said it publicly, but everyone was thinking the same thing. Was this communication, or a natural echo of something ancient, the universe speaking in its original tongue? And then, as quietly as it began, the signal faded. By January 2nd, 2026, it was gone. No more rhythm, no more heartbeat. Just the cosmic background hum of a silent universe once again. But silence in science doesn't mean nothing. It means waiting. Because somewhere in the data buried in terabytes of readings, the team at NASA found something else. One final pulse, a closing tone. When translated into visual data, it formed a spiral pattern identical to the one seen in amino acid simulations, the chirality curve of living molecules, left-handed, like life on Earth. Dr. Michelle Thaler said quietly, "If it's coincidence, it's the most poetic one the universe has ever written." For weeks afterward, the world's media exploded alien signal life from the stars, the pulse of creation. But the scientists remained silent, because no one could explain how empty space could sing back. Still, for those who listened late that night, through static and data streams and the faint hum of background radiation, some swore they could still hear it, a quiet rhythm, soft as breath, steady as time. Maybe the signal wasn't sent to us. Maybe we just happened to be listening when the universe whispered back. And if that's true, if sound can travel through silence, then maybe what we heard wasn't a message from beyond. Maybe it was an echo of ourselves. The news broke before dawn. A single headline flashing across screens worldwide: Earth receives signal linked to interstellar object. By sunrise, the world had changed. Airports filled with people staring at their phones. Traffic slowed on bridges. And in cities from New York to Tokyo, giant billboards replayed the same faint heartbeat, the sound from the void. Governments denied it at first. They called it interference, a natural magnetic echo. But when independent observatories across 5 continents released their recordings, all identical denials turned into silence. And that silence said more than any confirmation ever could. For the first time in history, every nation on Earth was listening to the same sound. And it wasn't a war. It wasn't a speech. It was something none of us could explain. In classrooms, teachers turned up the speakers and told their students, "Remember this. You'll tell your children about the day the universe spoke." In cathedrals and mosques, the rhythm echoed softly through ancient walls. Priests, monks, imams, all listening to a pulse that seemed to fit perfectly with prayer. Some said it was proof of God. Others said it was the music of physics itself, creation humming in the background of existence. Social media erupted. People began syncing lights, heartbeats, even city fountains to the 11-minute rhythm. Hashtags flooded the internet. The pulse, or echo, of life Raismai 3I Atlas. And yet beneath the wonder there was fear. If this signal wasn't random, what was it for? Was it a greeting, a warning, or simply the residue of something too vast for us to comprehend? At the United Nations, emergency sessions were called. Scientists stood beside diplomats trying to explain resonance patterns and electromagnetic memory, but the words communication and contact had already escaped into headlines. The world was awake, not just to the signal, but to a terrifying realization. For the first time, humanity wasn't alone in the conversation. Then, something unexpected happened. The signal began affecting human-made systems' faint but measurable phase shifts in radio networks, satellite timing, even heart monitors. Not interference exactly, more like synchronization. Everything with a natural rhythm, from pendulums to human pulse, began aligning subtly with the wave. No one understood why, but around the world people reported feeling calmer. Sleep patterns improved. Hospitals recorded lower stress responses in patients exposed to the frequency. The signal wasn't causing chaos. It was creating harmony. Dr. Avi Loeb, in an interview with the BBC, smiled and said, "Maybe the signal isn't telling us anything. Maybe it's reminding us of something we forgot, that we're all made of the same cosmic matter." Theologians called it the shared vibration of creation. Neuroscientists called it entrainment. But poets, musicians, and children called it what it felt like, the heartbeat of the stars. Within a week, major cities dimmed their lights once a night, synchronizing with the pulse, not as worship, but as recognition. The planet breathing in rhythm with something far beyond it. The oceans, the wind, the flicker of electricity, all seemingly in tune. For the first time since the dawn of civilization, Earth wasn't divided by religion, language, or borders. It was united not by fear, but by awe. Still, not everyone believed. Some said it was manipulation, a side effect of radiation. Others whispered of secret projects, that maybe 3I Atlas wasn't natural at all, that somewhere someone had built it, and that this signal was a call not to us, but to something else out there. And yet, on that night, when the final global synchronization occurred, when the whole planet fell silent at once, you could stand anywhere on Earth from the Arctic to the Sahara and feel it. A faint tremor in the air, a rhythm in the wind, a heartbeat not just heard, but shared. For the first time, humanity felt less like an accident of evolution, and more like a note in a larger cosmic symphony. For the first time in months, the world was quiet again. The pulse that had connected every city, every machine, every human heart was gone. No more synchronized lights, no more rhythmic echoes, only silence. And yet, it didn't feel empty. It felt full, as if the absence of the sound had left something behind, a memory imprinted into the atmosphere itself. In the high desert of Chile, the dishes at Alma stood motionless under the stars. They had listened to the heartbeat of the cosmos, and now they listened to its silence. Technicians replayed the last recorded wave again and again, hoping to catch a hidden message in the static. But there was nothing new, only that faint hum, now so soft that even the machines seemed to sigh. At NASA, data teams continued to analyze terabytes of readings from the final days of the signal. Deep within those files, an unexpected pattern appeared, a long, slow drop in frequency, like a cosmic exhale. Mathematically, it resembled the cooling curve of a dying star. But here it was happening across the vacuum, where no heat, no energy should have changed at all. Something had passed. Something vast yet gentle had left its trace in the very geometry of space-time. Dr. Avi Loeb wrote in his report, "The universe itself seems to be relaxing, as if an immense chord has been struck and now fades into resonance." Meanwhile, around the world, humanity was different. The streets were calmer, stock markets steadier. For weeks, even global conflicts seemed to quiet, as though the silence had balanced something inside the human psyche, tuning us briefly to a frequency of peace. In small villages, children asked their teachers, "Will the stars sing again?" And the teacher smiled softly and said, Maybe they never stopped. Maybe we just stopped listening. Philosophers called it the Great Stillness. Poets wrote of the soundless song. Neuroscientists studied the post-signal calm effect, finding subtle neural coherence among people who had listened to the pulse. Even plants showed changes in growth cycles during those weeks, as if the rhythm had brushed across every living cell on Earth. Then, one evening at the Atacama Desert, a group of scientists gathered near the silent dishes of Alma. They didn't bring instruments, just themselves. They stood quietly looking at the horizon where the stars met the sand, the same stars that had once carried the pulse to them. Someone whispered, "Do you think it was trying to tell us something?" And another answered, "Maybe it already did." The silence felt alive, vast, comforting, infinite. It was no longer frightening. Because for the first time humanity understood something ancient, that silence isn't the absence of sound. It's the presence of everything that sound comes from. When NASA released its final summary weeks later, it concluded with one line, not scientific but poetic. If consciousness exists across the universe, then perhaps it speaks in rhythm and listens in silence. That single line spread faster than any headline. People quoted it on walls in songs and whispers because somewhere deep inside it felt true. And in the months that followed, as telescopes turned once again to Mars and the blackness beyond the universe remained quiet, but every so often, deep in the static of cosmic background radiation, a faint tremor still appeared too weak to record, too rhythmic to ignore. Just one pulse, soft, almost human. Maybe it was the last echo of 3I Atlas. Maybe it was Earth answering back, or maybe it was the sound of the universe remembering itself. For months the world slept beneath quiet stars. The pulse had vanished. The skies were silent again. But silence, like darkness, never lasts forever. It began on a cold morning in late March 2026. A telescope in the Canary Islands recorded a faint shimmer, a glint moving through the same region of space where 3I Atlas had once passed. At first it was dismissed as debris, a fragment of ice, a trick of light. But within hours, observatories across Chile, Australia, and Japan saw it too. Same coordinates, same trajectory. And then, something different. The shimmer wasn't drifting, it was accelerating. Not wildly, not like a rocket, but with a kind of grace, as if it was being drawn back toward the sun. The data was clear. The object was no longer following a ballistic path. It was adjusting course. Dr. Avi Loeb described it simply. It's as if gravity has let go and something else has taken over. Across the world, telescopes pivoted. For the first time since the silence, humanity turned its eyes back to the void. And in the darkness, they saw it, not a single light, but many. Tiny points of blue-white illumination scattered along the same orbital plane like sparks left by a match drawn across space. Each one pulsed faintly in time with a familiar rhythm, every 11 minutes and 4 seconds. The pulse was back. But this time it wasn't a sound. It was light. NASA's James Webb Space Telescope caught the first clear image. A narrow band of glowing material stretching for millions of kilometers, luminous dust, charged particles, and what appeared to be crystalline fragments reflecting ultraviolet light. Spectral analysis showed the same chemical signature as 3I Atlas polycyclic aromatic hydrocarbons, hydrogen cyanide, and trace amino compounds. But now they were organized, aligned along a filament structure, like a thread of DNA stretching across space. Dr. Michelle Thaler stared at the data and whispered, "It's beautiful. It's like the universe just exhaled life into light." As more telescopes joined the watch, the pattern became undeniable. The fragments weren't random. They were synchronized, moving in harmonic motion, pulsing in the same rhythm as the long-lost signal. It wasn't just a remnant. It was a response. Around the world, people gathered once more in cities and deserts on rooftops to watch the night sky flicker with soft blue light. In some places, faint ripples of luminescence even appeared in the upper atmosphere, glowing arcs that shimmered for a few seconds and then faded as if Earth itself was answering back. Scientists called it photon entrainment. Poets called it the sky remembering. In laboratories, computer models showed that the filament structure of light followed an almost biological pattern energy flow through nodes, feedback loops, and resonance frequencies nearly identical to neural activity in the human brain. It wasn't alive, but it behaved as if it wanted to be. And as the data came together, a single hypothesis began to emerge, one so bold that even the most cautious physicists hesitated to say it aloud. What if the universe is not only capable of creating life, but of learning from it? Because every equation, every model, every observation pointed to one truth: the pulse had changed. It wasn't repeating. It was evolving. And that meant something out there was still listening. That night, when the last observatory shut down for the evening, the faint glow lingered just above the horizon, a thin band of blue and white tracing the curve of the Earth. It pulsed one last time and faded into dawn. But for those awake to see it, scientists, dreamers, children staring from their windows, it felt like a promise, not of contact, not of discovery, but of continuation. The silence was over. The universe had spoken again, not in sound, but in light. And perhaps this time, it was waiting for our reply. Light travels fast, but memory travels forever. Months after the reappearance of the pulse, the glow faded from Earth's skies once again. Yet somewhere far beyond the orbit of Neptune, that same light, the light born from 3I Atlas, continued on. Every photon, a messenger. Every particle, a story. NASA's deep space sensors picked up faint residual signals moving toward the edge of the heliosphere, tiny waves of polarized radiation encoded with repeating intervals the same 11-minute pattern. But this time the amplitude was weaker, the rhythm slower, like a heartbeat easing into sleep. Dr. Michelle Thaler said quietly in an interview, "It's like watching the last echo of a dream drift away." Astronomers began tracking the photons as they crossed into interstellar space. Each wavelength stretched, redshifted, scattered, but the pattern endured. Even across trillions of kilometers, the light refused to vanish completely. It was a strange paradox. The farther it traveled, the fainter it became, yet the more stable its rhythm grew. Some called it the persistence field. Others called it the memory of the stars. And the metaphor wasn't lost on anyone, because in a way, stars themselves are memory. The calcium in our bones, the iron in our blood, all forged in stellar furnaces billions of years before our sun existed. We are the universe remembering itself, and now maybe it was remembering us. When data from the Voyager 1 probe was reanalyzed, engineers found a faint modulation buried in its plasma readings, not sent by humans, not random noise. It matched the same harmonic ratio detected in the 3I Atlas light pattern. Voyager, drifting alone for 48 years, had caught the whisper of a message long after it should have been silent. Dr. Avi Loeb wrote in a private note, "Perhaps information itself is indestructible. Perhaps the universe stores memory the way matter stores gravity, invisible but eternal." Scientists debated it endlessly. Was this resonance a coincidence, or could light through interference and entanglement actually preserve the history of what it touched? A team at CERN ran simulations projecting how photon interference could encode complexity over cosmic time. The result was stunning. In the right conditions, overlapping wave patterns could theoretically reconstruct past energy states. In other words, light could remember. If true, it meant that somewhere deep in the interstellar medium, the story of 3I Atlas was still unfolding, not as data in computers, but as geometry and radiation. Artists called it the ghost of a traveler. Physicists called it quantum persistence. Philosophers simply called it hope. Because for the first time, the idea of memory stretched beyond biology, beyond technology, into the fabric of space itself. And so even as the light disappeared into the dark between stars, telescopes continued to listen. Every few months, a new anomaly appeared, faint oscillations, aligned with no known source flickering like candlelight across the galaxy. Maybe echoes, maybe siblings, maybe the universe telling and retelling the same story through different tongues of light. At the European Southern Observatory, a researcher wrote a single line in her log. Every star remembers what it shines upon. That night, she turned off her monitor and stepped outside. The sky above was endless billions of suns, billions of memories. Somewhere among them, 3I Atlas was still moving, still glowing faintly, carrying the memory of a world that once listened. Maybe that's all consciousness, is the universe learning to remember itself through us. And if that's true, then every photon, every heartbeat, every story, even this one will never really be lost. 2 years passed. The light was gone. The world had moved on. The silence after 3I Atlas had become part of everyday life, a memory fading into myth. Children grew up hearing bedtime stories about the pulse that once united the planet. Scientists went back to their equations, politicians to their meetings and the universe, back to its quiet rhythm. Until one night in late May 2028, the quiet broke. It began at a small radio telescope in Namibia, a faint repeating signal barely stronger than background noise. A low, rhythmic hum pulsing every 11 minutes and 4 seconds. The same interval, the same tone, but different somehow, deeper, slower, older. The technician on duty thought it was a glitch. Then, 2 hours later, observatories in Chile and Japan confirmed the same thing. 3 stations, 3 hemispheres, 1 pulse. When the signal was converted into audio, the sound wasn't like the first one. It carried harmonics, faint echoes overlapping the main tone, like multiple voices whispering in the same key. Not random, not noise, structured, layered. Dr. Avi Loeb, now retired but still restless, received the data that morning. He looked at it for a long time silent. Then he whispered almost to himself. It found a mirror. What he meant was this: the frequency was not coming from deep space, but toward it. The signal appeared to bounce between Earth and an invisible point billions of kilometers away, as if something out there was answering in phase 1 cycle behind. The team at CERN and NASA JPL ran simulations. If the reflection were real, it would suggest that light from 3I Atlas had encountered something, a cloud, a structure, maybe even another object capable of amplifying the original resonance and sending it back. Only this time the delay matched exactly twice the travel time between Earth and the edge of the solar system. In other words, the universe had echoed back. The implications were staggering. The signal's harmonic layers contained frequencies far below what human instruments could produce, almost gravitational in depth. And when those frequencies were visualized, they formed a shape that chilled even the most rational scientists, a faint spiral nearly identical to DNA. At first, no one believed it, but the math didn't lie. This was no reflection from dust or gas. It was a structured, rhythmic feedback from something vast, distant, and deliberate. For the first time, astrophysicists proposed a theory once thought impossible, that information once released into the cosmos could be reflected, restructured, and returned not as a simple echo, but as a response shaped by the universe itself. It was as if the cosmos had heard our story and was now retelling it. Dr. Michelle Thaler, watching the live data feed, said quietly, "Maybe the echo is not repeating us. Maybe it's learning from us." In the following days, the pulse stabilized. The rhythm remained steady, calm, unwavering, like a breath returning to a sleeping body. And then, after exactly 7 rotations, it faded again. Gone. But not before leaving one last trace. A final data frame captured by ALMA showed a faint flicker of light just above Mars's orbit. Not a comet, not an asteroid. A reflection. Same spectral signature, same composition, same molecular fingerprint as 3I Atlas. It had come back. Not the same body, not the same mass, but something born from it. A fragment, perhaps, or a seed. Somewhere beyond the red planet, a new object was moving, slow, silent, pulsing, faintly blue. And once again the universe was listening. When the echo faded, it left behind something strange, not in the signal itself, but in the data between the signals. Hidden in the harmonic interference, scientists began noticing irregularities, gaps that shouldn't exist, and frequencies that shifted subtly each cycle. At first, they thought it was interference from solar wind or equipment noise, but as the data came in from multiple observatories, the pattern repeated perfectly across hemispheres, identical noise in identical timing. That was impossible. Dr. Michelle Thaler was the first to visualize the frequency plot in 3D space. What emerged wasn't random at all. It looked like a shape. Tiny arcs, spirals, and wave nodes connected by ratios, the kind of ratios found in molecular bonds and organic symmetry. When overlaid with biological data, the pattern matched something extraordinary: the spectral geometry of adenine, one of the 4 base components of DNA. A stunned silence filled the control room. For a moment, no one spoke. And then softly, Michelle said, "It's not speaking to us. It's showing us what we are." NASA cross-referenced the frequencies using particle simulations at CERN and Los Alamos. The resonance could be recreated by aligning high-energy photons in a specific interference lattice, a light-based molecular template. In other words, the signal wasn't just sound, it was instruction. When reconstructed visually, the pattern formed a rotating 3D lattice resembling the double helix of DNA, except it wasn't made of molecules. It was made of light. Physicists called it photonic biocode. It wasn't information in words or math or binary, it was a pattern that builds itself. A universal signature of complexity, one that could, in theory, seed the architecture of life anywhere photons and matter intersect. If true, this would mean 3I Atlas wasn't merely an interstellar traveler, it was a carrier, a vessel for memory, not human, not biological, but universal, a message encoded in the laws of physics themselves. For months, research centers around the world tried to decode deeper layers of the data. What they found next was even stranger. The frequency harmonics changed slightly when translated through Earth's magnetic field, as if adapting to local conditions. The code was responding. At the Max Planck Institute, a supercomputer mapped every known amino compound against the harmonic pattern. The result, over 70% correspondence with not only DNA, but protein folding structures. It was as if the signal contained a blueprint of evolution itself. But the real revelation came from a single insight. The signal wasn't instructing how to create life, it was showing why life repeats. Dr. Avi Loeb, now 74, summarized it perfectly. It's not a message from another civilization. It's a reflection from the same equation that made both of us. In other words, the signal didn't come from aliens. It came through the universe through the same physical constants that shape atom cells and stars. A universal self-recognition. For the first time, humanity realized something profound. We had been searching for intelligent life in space, but perhaps intelligence was already woven into the light that made everything. And as the world digested that truth, the final data set revealed one last anomaly, a faint modulation at the edge of the waveform, repeating 4 times. 4 beats, 4 pulses, just like the 4 bases of DNA. A signature, a mirror, a message written not in language but in existence itself.